Hi folks, we're going to take a look at these derivatives involving trigonometric functions. So this is page 263, numbers 3b, e, and f. Okay, let's take a look at b. So here I see the tangent function, but I'm not taking the derivative of tan x, but tan of 3x. So I'm going to need to use the chain rule. So this is going to be my u. So first thing I do is I take the derivative of tan u, which is secant squared u. So secant squared of 3x, and then I have to multiply that by the derivative of u with respect to x. So the derivative of 3x is just 3. Okay, and I'm not really going to go out of my way to simplify these here. All right, so that's it for b. Let's go to e. I'm going to give myself a little more room here. Now here I see that I've got sine of 2x being multiplied by e to the 3x. So I'm going to have to use the product rule. Okay, but I notice that in taking each of the individual derivatives, I'm going to have to use a chain rule. All right, so let's start by beginning the product rule here. So derivative of the first function. So again, here my 2x is going to be my u. So derivative of sine u is just cos of u. Okay, so cos of 2x, and then times the derivative of u with respect to x. Derivative of 2x is just 2. Okay, and then multiply that by the second function. Okay, and then plus. Here now, it's then going to be the first function, so sine of 2x. Okay, and then multiply that by the derivative of e to the 3x. But again, we're going to have to use the chain rule here. So my 3x here, I'll let that be my v. So the derivative of e to the v is just e to the v. So e to the 3x. And then times the derivative of 3x, which is just 3. Okay. Now, if I were to simplify this here, I do see that there's a common factor of e to the 3x. So let me go ahead maybe and simplify this as much as I can. So here, take out the e to the 3x, see if there's anything else. No factors of 2 and 3, so nothing common. So what we're left with then is 2 cos 2x, okay, and then plus 3 sine 2x. Okay, and at this point here, I don't really see any need to try to go any further. There's no point in necessarily expanding either cos 2x or sine 2x. All right, so let's move on to f. So here, again, what I'm going to do to make my life a little easier, I'm actually going to rewrite this. Okay, instead of this square, writing it in our shorthand form, let me write it so that it very clearly identifies what's going on. So what this means when we've got the square above the cos is it means that the whole cosine expression, so cos of 2x, this whole thing is being squared. Okay, this makes it a little easier to see how the chain rule is going to be used. Okay, so I see that my outermost function is the square, so I think of this as u squared, and the derivative of u squared is just 2u, so 2 times cos of 2x. Okay, and now I'm going to take the derivative of that interior function, derivative of u with respect to x, but here I see that I'm going to need to use the chain rule again, because I don't have cos x, I have cos of 2x. So I'll make my 2x be v. So the derivative of cos v is negative sine v, so negative sine of 2x. And then finally, I can take the derivative of 2x with respect to x, which is just 2. Okay, there's not really much simplifying that I can do here other than multiplying the constants. All right. So just to recap these, in most scenarios, I needed to use a chain rule. So anytime I have something more complex than just the basic function, so here it wasn't tan x, tan of 3x, instead of sine of x, sine of 2x, I'm going to need to use the chain rule. And then, of course, in conjunction with any other derivative rules like the product rule. And in this case here, I actually needed to use the chain rule a couple of times. Okay, that's it for these.